Okay, let's quickly deal with electrical power. From the definition of electrical power, it simply states that power is the time taken to get work done. Basically, that's it. We could use more complicated language, but basically that will serve our purposes. So, looking at it, power is the time in which work is done, or the rate at which work is done. Now remember, we're talking about electricity is equal to, right? So that being the case, power is work done over time. Now, just to make things a bit simpler, we might want to use more simplified symbols, right? So we can use P for power, W for work, and T for time. Now, don't forget that from the formula for work, what will we be able to imply? That work is the same thing as electrical energy, right? That's what we just dealt with previously. Electrical energy means the same thing as work. So, you taking that into consideration, we could then go to the next point and say, since work is equals to electrical energy, and what's the formula for electrical energy? I, right? VT, right? Which was the first this thing we did. And we divide it by T. And doing that, we now get, since they will all cancel each other out, the upper T will cancel the lower T. We now have power is equals to IV. We could call that equation 1. Okay? That's our equation 1. Next, let's remembering that V is equal to IR, and we can now replace V in that equation, which we just discovered, that which is equation 1. Let me put it again so that we can be on the same page. So this is our equation 1, P is equal to IV. If we replace V with IR, what do we now have? We now have P is equals to, well, let's just put everything, I into I, okay? And then, which gives us what? I square R, right? And that we call it equation 2. Okay, that's relatively simple, I suppose, right? Equation 2. Okay, now, using Ohm's law again, since we know that V is equals to IR, what if we want to make I the subject of the formula? What do we have? We now have I is equals to V over R, right? We can then substitute that into our equation as we replace I square with V over R, right? So our new formula for power will now be, so simplifying it, we now get V over R all square times R, right? And let's simplify it further. P, which is power, is now equal to, now this will now give us V square over R square times R, right? And you know, there's an R at the top and 1 at the bottom, so they will both cancel each other out, I suppose. You are quite familiar with that concept. And once they cancel each other, we'll now have our final answer, which will now be, so our final answer will now be V square over R. For a quick example, please take down this question and we'll try it together. Calculate the power dissipated by a heater of 220 volts and resistance of 10 ohms. Now don't forget that what a heater is your boiling ring your kettle, electric kettle at home, anything of that sort, even your water heater in your house, it still can be referred to or regarded as such. So, now what is the purpose of having this knowledge? Well, you know, there are so many ways in which these things are useful. You could use it to determine the time that whatever use you're putting that equipment to would become useful. You could use it to maybe find out how much energy you're going to be consuming in your house based on what devices you're using, and so on and so forth. So let's solve this. So first of all, let's put down our data. What data were we given? We were told that the heater has a voltage of 220 volts. So let's put that down. And then what else were we given? And now we're given a resistance of 10 ohms. Now, by virtue of looking at this, we can see that we're told to find the power that will be dissipated. Whether it's the power being dissipated or the power being inputted is probably going to be considered as almost the same thing. Of course, that's assuming that there are no losses in some form. We'll do that in the later class. But for now, let's just say the power dissipated, which means the power that is being used by this device, the heater in this case. So we have P is equals to what? Now we had a lot of formulas which we derived from the previous section, and if you look at them, you'll probably be able to see that one of these formulas is the most useful to achieve our aim. So we now have this formula, which is P is equals to, so looking at that, we have 220 squared, which is our voltage, over 10, which is our resistance. And that will then give us, it will now give us 4,840 watts. Okay, and looking at that, 4,840 watts can be simplified further into kilowatts, which will give us, now remember we're dividing by 1000, right? So it will be 4.84 kilowatts, right? This just looks neater and it's less bulky. So remember, we divide by 1000 to get kilo, and watts is the SI unit for power. So we'll stop there, and I hope this was helpful, and have a pleasant day.